Hey, what's up, everyone? Good morning, if this is morning when you're watching this. I am going to start our next video from page 282. And in order to be ready for this video, I really recommend that you have protractor, highlighter, something to write with, and then those note cards that we were creating in the previous three videos, page 279 and onward. So let's get into it. Now, what we're going to be talking about in this video is what we can do with adding angles. And this is directly related to the learning targets from a couple of lessons or pages ago that we are going to apply real number properties to angle measures, line segments, and distances. We're continuing activity 1, and so in the previous video for activity 1, which was page 281, we talked about how we could use the note cards for addition property of equality or substitution property, and I recommended that you write the definition and the example on the back of your card. So if you haven't done those, go back and watch that video and then do them, okay? But have them handy. Let's get into it with a highlighter. And so in this one, we're going to start here. You can use the addition property of equality with angle measures, segment measures, and distances. You know, those are important things to recognize, so I'm going to underline them, and underline them, and underline them. And then I'm also going to highlight the addition property of equality because that's the key vocabulary word that we're using here, right? So, for example, with angle measures, right? With angle measures, we are able to say, you know what? If there's this thing that's an equality statement, we're saying angle 1 and angle 3 are equal. Well, let's look at the diagram. Angle 1 is right here, and angle 3 is right there. And we're saying that they're equal, all right? In fact, they are. They are because they're vertical angles. And there's something we're going to do later on in this lesson with some formal, or it happened in a previous section, but vertical angles are actually equal. So that's what those are. Those are vertical angles. And if we add angle 2, so that's this angle right here. If we add angle 2 to angle 1, all right, the measure of angle 1 plus the measure of angle 2. So whatever this amount is, and we add to it this amount over here, together, that's a new amount. Hint, it's 180 degrees. And the reason is it's a linear pair, and a linear pair is supplementary. And if a linear pair is supplementary, then that means it adds up to 180 degrees. I'm going to see if I can quick grab one of my other note cards that says this. Now, here we go. The linear pair postulate. It says that if you add two angles together and they make a straight line, then they must add up to 180 degrees. Let's look at the other side of the equal sign, though. The measure of angle 3, yep, that's on the right side of the original equal sign, plus the measure of angle 2. So now we're going to add angle 3 and angle 2 together, and sure enough, they also make a straight line. And it turns out they happen to equal 180. So there you have it. Those two angles, using the addition property of equality, we can add the same thing to both sides of the equation. And when we add the same thing to both sides of the equation, that's this and this, the measure of angle 2, you still have an equal statement. Segment measures. Okay, so the addition property of equality. Let's talk about what we can do with segment addition. And I know I've got one of the vocab words here: substitution, reflexive, subtraction. Here we go. Segment addition postulate. The segment addition postulate says if you have a point that's in the middle of a line segment, well, then it breaks that whole line segment up into two segments, and you can still add them together and make that be equal to the whole segment. Okay, so we have AB, and it might, like in highlight, right? We have AB, and we have CD. All right, so CD is there. We're saying from the get-go, those are equal things. Now we're going to add a common line in the middle. We're going to add BC, so that's this one. We're going to add that middle segment together. And we're going to add BC to both sides. Notice how they kind of switch it around, right? BC comes after AB, so they put it after AB on the left side of the equation. BC comes before, to the left of CD, so we're going to add it to the left of this CD here. Well, that means that this whole segment is the same length as that whole segment. And if you really want to be sure about it, we can actually go ahead and measure. So I'm going to use centimeters. It's a 1 centimeter line segment. That's AB is 1 centimeter. CD is 1 centimeter. And we're going to add, that's how I know they're equal. The ruler says they're equal. Also, the supposition says we're equal. And then I'm going to go and measure BC. And BC in the middle looks to be like 1.3 centimeters. So 1 centimeter plus 1.3 is 2.3 centimeters. And then this 1 centimeter plus the same distance, the 1.3 centimeters, together also adds to 2.3 centimeters. So they are, in fact, equal. If AB equals CD, so we're still talking about the addition property of equality, and we've actually taken off the lines. Like AB, we don't have to write it measure of line segment AB. We can just put AB with those 2 letters, and that means the same thing. How long is that? 1 equals 1, because 1 centimeter, right? Then AB plus BC, so that's 1 plus 1.3 equals 1.3 plus 1. Now, this 1.3 has to line up with the BC. That's why it's switched. But it is true. You get 2.3 for both of them. And so, therefore, the addition property of equality still works. Works for segment addition. It works for, where'd it go? Angle addition. Again, I've written all of them down. I really recommend that you do the same too. Angle addition as well. Let's try it out. Let's see if the subtraction property of equality works. All right. In fact, for the length of time, I'm going to say that's part B to this video. So finish this video out. Thank you for taking some notes and highlighting along the way. Let's get into question 2 in the next video. Thanks.